We're going to continue here. Okay. Apparently the recording was still recording while we were outside. Yeah, it's fine. They can fast forward. It'll be all right. Okay, so first of all, in this class, you need to make sure if you are taking physics that you check your calculator every single time. We should always be in radian mode. And I always say flush left. For those of you that had Mrs. Kim, she always tells you to clear your memory. But I'm going to give you something later on when we start getting into it that you're going to save in y equals. So I don't like to clear my memory because then you have to keep typing it in. It sort of defeats the purpose. Because for those of us that are going to be sitting for the AP exam, they do not clear your memory. So that's the good news. You have stuff in here, they're not going to clear it out. So when you go into your mode, you need to make sure you are flush left. Everything should be on the left-hand side. Okay, so that's what I mean by flush left. So I would get in the habit of checking that on the regular basis. All right, so we're going to go into y equals, and we're going to put this function in, because what we want to do is evaluate this limit. So ideally, when we're evaluating a limit algebraically, what we want to be able to do is use direct substitution. That is the best, easiest, and fastest way to evaluate a limit. The problem is it doesn't always work. So sometimes we will have to use other methods, and one of those methods would be using the calculator. So what we're looking at here is the limit as x approaches 0 of the sine of x over x. So if we use direct substitution, the sine of 0 is what? Sine of 0 is? 0, thank you, over 0. Okay, is that undefined? 0 over 0? That's even more special. It's called indeterminate, meaning you can't determine anything. You can't even say that it's undefined. And we'll get into those situations later. So the issue here is we cannot evaluate this algebraically. Eventually, when we learn L'Hopital's, you will be able to evaluate it algebraically. But right now, even if you do know it, you need to pretend that you don't. We cannot. So we know that if we plug in 0, we get an undefined value. Okay, it is indeterminate, but basically that point would be undefined. So what we want to do is we want to see what is happening to this graph, what's the behavior of the function as x is approaching 0 from both sides. So we're going to use a table to evaluate. So the first thing you want to do is go into y equals, and for those of us that have the fraction function, remember it's alpha y equals, and it says n slash d, which means numerator over denominator. I like to use that because then it looks exactly like what I have on my paper. Okay, so this is what you want to put in y sub 1. Okay, I'm cheating. I already have this in y sub 2 because I have to do it 3 times. Okay, so the other thing that we want to do is find out what these values are in the table. So if you go into the table right now, this is what you have. You have an automatic setting. And the way we change this is we go into second window, okay, and we can change the table by any value that we want. 1s, by 2s, by 5s, by 20s, by decimals, okay? And more specifically, we can change where we're starting. But what we're going to be looking for is we want very specific values, okay? So our independent is our x value. The dependent is the y value. You want to leave the dependent on auto because you want the calculator to automatically plug in what you're asking for. So we're going to change this to ask. Okay, and when we go into the table, mine might actually have something. Oh, no, it's blank. It's exactly what you want. You want it to be blank, so we're not going to panic. What we're going to do is we are going to evaluate from the left and see what the behavior is, and then from the right. So when we approach 0 from the left, this is the furthest value from 0 that we have here in this table, because as I move to the right, I'm getting closer to 0. So we're going to plug in negative 0.1, negative 0.01, and negative 0.001. I just plugged in all 3 of these values right here in the table. Okay, now, we notice that we get a y value, and even though in this class, for the most part, you will be rounding to 3 decimal places, I'm going to put all these values in here. This is 0.99833. Then I've got 0.999998. And even though this says that this value is 1, I'm going to go over here and just show you what it did. So we can only fit 1, 2, 3, 4, 5 values in this column because that's as wide as it is, but look at this value. So they did round it to 1, but ideally it's how many? 1, 2, 3, 4, 5, 6, 9s. So I'm just going to exaggerate here. 6, and then 8, and then a 3 repeating. Okay, so it did, the calculator automatically rounded to a 1, but I just wanted to show you what was happening. So then we're going to do the same thing. We're going to approach from the right-hand side, but I want you to plug this one in first. So when I go down here, I'll plug in 0.1, 0.01, 0.001. And when I go here, you look, it's the exact same value, right? So we've got 0.99833. Forgot my point. And I've got 1, 2, 3, 4. And this is the exact same value, 0.9. What do I have, 6 of these? 3, 4, 5, 6, 8, 3, repeating. Okay. So we're approaching graphically, tabularly, 0 from the left and from the right. It's pretty obvious using the table what's happening. I don't even have to look at the graph. Do you agree? What's happening? What is the limit as x approaches 0? Yeah, 1. Okay? So if you were asked to fill out a table and evaluate the limit as x approaches, in this case 0 or whatever the value is, everybody's good. Yeah? Okay. So sometimes, and I know your directions look different from this. I fixed it because there was a typo. What we want to do is use the table to find the limit, and then we're going to verify using a graph. Okay, so first of all, if I were to plug in 0, what's the cosine of 0?
1.
It is 1. So 1 minus 1 is 0 over 0. So again, we're indeterminate or basically undefined. Okay? I'm going to go into y equals, and I will put in this function right here. And then I'm going to go back into the table. Okay, so do me a favor and fill out the table as you approach from the left and from the right. Don't do anything else. Don't look at the graph. Just fill in as you approach from the left and from the right. Do your values agree with mine? Yes? No?
Yes.
Okay. So I have a quick question. If I gave you just the table like this, I know you're predisposed to the function right now, but if I just gave you the table, no function, I said the top are your x values, the bottom are your corresponding y values, can you determine the limit of f of x, now remember you don't know what f of x is, as x approaches 0? You can. You don't know anything about this function, you just have a series of points. Okay. Ideally, it would be nice if we could say, yeah, I could determine that, but technically you can't. If you don't have the function and if you don't have a graph, you don't have enough information to tell me what this table is. It could be arbitrarily chosen values. It could look like there's a pattern, but there is not enough information here. Does everybody understand what I'm saying? In order for you to make a distinction that, okay, yeah, the limit as x approaches 0 is, what are you guys saying? Some of you were saying something, some of you were saying nothing. How many of you are unsure? Hands. So all of you know what it is, you're just choosing not to say anything. So you're unsure, I'm unsure. I don't know what's happening. Because what we saw before, it's okay. Friendly, safe environment, folks. Okay, but what we're saying here is, in the previous problem we saw, it was very obvious. 0.99999 from either side, right? It was definitely 1. Okay, but here, the pattern doesn't look the same. And without the function and without a graph, we cannot make a distinction. I don't know, they're just basic numbers. Someone put them in there. Okay, now we have the function, and we can actually look at the graph. So if you cannot tell what's happening, because it's not making sense to you, it's just, I'm not seeing the connection here, I don't see what's happening because on this side it's negative, and on this side it's positive, I can't picture the graph. That's why we have these cool calculators. So this is what we're going to do. We're going to go into Zoom 7 because it's a trig function. Okay? Now I can see what's happening. As I approach from the left, does it make sense as to why my y values are negative? Yes? Okay, and what about from the right? They're positive. But as I approach from either side, where am I going? To 0. Now does this make sense? We have a graphic. Okay, so now your answer here is equal to 0. Okay, so sometimes you are going to need the graph. Sometimes I cannot tie it all together just with the table. Okay, questions about those two? So if you have to fill out a table and evaluate the limit, can you do it? Yeah. What about if you can't see the pattern, you know how to get the graph? Okay, are you always going to use Zoom trig? No, I mean, this has a trig function in it, but if it doesn't have a trig function, you don't need it, Zoom 6 or whatever. Okay, you need to know how to use your calculator, all right? Okay, so a couple things that we need to talk about here. True and false. I know not your favorite, okay, but sometimes we have true and false. There are some occasions where sometimes the answer is true, sometimes it's false. So if you are given a plain old true false in this class, if there is one scenario, just one, that will make the statement or question false, then the answer is false, even if it's just sometimes. Okay, it's either all true or you got something that's going to negate it and it's going to be false. So you would provide that example. So that is what we're looking at here. So what we want to do is determine if the statement is sometimes, always, or never true, and we want to use the properties that we learned in terms of evaluating limits to make this decision. So here it says, if the limit as x approaches 2 of our given function does not exist, then the limit as x approaches 2 from the right does not exist. So what you need to think about is, what's going to make the limit as x approaches 2 overall not exist? Okay, they don't meet, but is it possible that the limit from the right would still exist? Yes. Okay, so is this sometimes, always, or never true? Sometimes. Okay, so let's take a look. Okay, so this statement would be true if you had a graph that was approaching from the right and x equals 2 is a vertical asymptote. So this is what I mean. If we have a graph like this, so if this is 2 and I have a vertical asymptote here, they're saying that if the limit as x approaches 2 from the right does not exist, the only time that's going to happen is if the graph goes to either positive or negative infinity from the right-hand side. Okay, so this is just one scenario, but that means my graph would go like this from the right. And then, I don't know, maybe it could go like this from the left, and it goes to a point. I just made that up. Okay, but really what I'm concerned with is what they made in the statement that they made here. The limit as x approaches 2 from the right, coming from the right, does not exist. Okay, boom, right here. So that means the limit overall is not going to exist. However, what would make this false is this scenario. If I have a graph like this, okay, and here I have 1, 2, I'm approaching from the right, I don't know, like this, and I'm approaching from the left. So this is open, this is closed. Again, just made up the graph, doesn't really matter. So the limit as x approaches 2 does not exist, but when I approach from the right, I don't know, maybe this is 2. So if I have 1, 2, and then this would be 3. Okay, so this is what makes it false. That's just one scenario, and that's all you need is one. Everybody good? Okay, so what about if the limit as x approaches 2 from the right does not exist, then the overall limit as x approaches 2 does not exist. This is always true. Okay? Does everyone understand why it's always true? You don't need a graph, you don't need an explanation. Everybody's okay. Awesome. Okay.